Welcome to Technically Speaking. I'm Steve Brown. I'm the product manager here in White Bear Lake, Minnesota for press brake tooling. And today we've selected a topic that's very common, bending and offset. Your customer sends you a print, you need to select a tool, and we've got to figure out the best way to do that. So we can go through a selection process here today, take a look at that drawing that your customer sent, and then how do I select the tool to make the offset? And then we'll actually show you some CAD type of drawings so you can see what's happening very clearly, and then we'll go out to the press brake and we'll actually bend the material for you. So without further ado, let's take a look at that customer print that is sent to you. Let's just take a look at the offset detail. We're going to look at this and say, geez, I need to have an offset tool that when I come to a complete stroke to the included angle, I get a 23mm offset and I need to pay for that. But if I just simply ask the customer, what's important to you? Height of the offset, or is it the angle of the offset? Those are two big questions. So you'll notice that the height of the offset is including one material thickness. So from top of material to top of form, we're going to call that the offset height. And if you look at the offset height of the tool, you'll see how that's called out. It's from the tip of one of the punches to the bottom of the V. That's the size of the offset tool. And then you've got the estimated resulting angle. So that's what we need to find out. The height of the offset and the angle, what's important to the customer. Okay, so now we have our definitions in place and we can take a look at the height of the offset and the angle. And we'll take a look at what's important to the customer. If they were to call out and say the angle and the offset's important, well then we're going to have to get into some sort of special tool. So what we're showing you here is just a splatter of a traditional type of tool made to a special size, or you've got maybe multiple radiuses. You're not going to be able to do that air bending with a balanced offset tool. And then you've got a horizontal type of offset tool for thinner materials. So just some options in the specials world. That's not what we're going to try to address today. The customer says the height of that offset's important, not necessarily the angle. I don't want it to be laying down flat, but you can have a variance of 90 degrees, even though we didn't call that out in the drawing. So now I've got these three samples, and you can see a 1/2-inch offset tool. All we did was control the stroke. And by controlling the stroke, we either made a 125, a 250, or a 425 offset using the same 1/2-inch offset tool. And we can do this because the load is balanced. The center line of those tools is balanced. So as I get force from one side for one bend, I get equal force on the other side for the other bend. And the plane will remain parallel. So that's the biggest question we're going to get asked. You're going to get asked, will the material flanges be parallel? And the answer is yes, it will. As long as you have proper alignment in your brake and you're using a precision type tool. Now let's just make sure we have the right tool really quick. Okay, there's a whole webinar on this, so I'm not going to go through this too much, but I will say if you're going to use a 313 offset tool, we're going to want to multiply that dimension by 1.414 to get our actual V opening size. So now you can do a double check real quick and ask yourself, if I had X material, whatever I'm dealing with, would I actually put that material into this V opening? And what we're going to show you out in the shop, we're going to use a 313 offset tool. So we're going to calculate that out to be somewhat close to a 10mm or a 394 V opening. And we're going to put 048 material into it. So I would go back to my air bend force chart, determine if I can put 048 material into a 10mm V opening, and know that I'm going to produce 1.5 to 2 times the tonnage that's being called out on the chart. You'd want to do that quick test before we go out and bend. But I think we're ready to go out to the brake, make some bends, and show you what actually happens. So I've got 4 different bends that I'm going to make for you here. And the first one, we're actually going to overstroke a little bit. We're going to come down and create a little bit of tonnage. And when we create that tonnage, something we didn't talk about, but you can actually overbend. So if you can see this bend is actually past 90. What it did is we hit the 90-degree included angle and it sprung in. We're going to take a little bit off of that stroke now. Let's take and make it a little bit closer to the 313 offset that we know that we can generate with this tool. And now you can see that's pretty close to 90. So we've just controlled the stroke, basically, the tonnage in this case, because we created a little bit on the last one, not so much on this. Let's back it off another little bit. And as we do, you'll see the bend is going to become more lazy. But you can also see that the plane of the material, it's parallel. So we don't have any deviation. We're happy with the height of our offset. And if you were to mate up a piece of material in between there, it would match. And the fourth bend, we'll back it off even a little bit more. Let's just back it off enough so that we have a very lazy offset. It's very lazy, but I'm still controlling the height. So if I wanted my offset to be this height, I could control the stroke and I would get great repeatability out of it. As long as you have the three common type of things that you need to air bend, which would include a precision tool, repeatability in your stroke, and consistency in your material. So now let's take a look at the bends that we just made on the press brake. And you can see there's the offset that was overbent. We actually applied extra tonnage to get it to spring in. Here's the bend that went to the included angle, 90 degrees. And here are the bends where we just back the stroke off, and you can see as we back the stroke off, the angle changes, and so does the height of the offset. So we could control that stroke to get our height, live with the angle, and we just saved a lot of time and money making tools in our tool room. So now we've taken that customer print, we've got a better understanding of whether they need an angle or a height or both. We've selected our tool. We potentially took a stock tool off the shelf and air bend that offset height that we need, and we've avoided contacting your tool room, having a special tool made up when they're busy. So you've got the tools now to potentially use a standard and still satisfy that customer print. So if you like what you saw, like us on YouTube, subscribe to our channel, send us comments on the email that you see on the screen. Let us know what you like, don't like, maybe a topic for the future. And technically speaking, now you know.